we're going to continue with question number 4 on your accumulation practice. Question 4 reads that the integral from 5 to negative 2 of negative 4 g of x dx is equal to what? Big question mark here. First thing I notice is that my lower limit seems to be higher than my upper limit, which is backwards. I really want my lower limit and my upper limit to read from left to right on my graph. So this definitely needs to be turned around. And I'm going to put the negative 2 first for my lower limit, and then my upper limit will be a 5. However, I need to throw a negative sign on the outside of the problem if I'm going to do that. And this is still negative 4 g of x dx. Okay? All I did was I switched my upper and lower limit and put a negative sign on the outside. Okay? So that my f of b minus f of a is now f of a minus f of b with a negation on it, and it means the same thing. Alright, now the negative 4 is going to move to the outside as well. And this is just going to give me a positive 4 on the outside between negative 2, and this is not a 5, this is a 3, if I'm not mistaken. So between negative 2 and 3 of g of x with respect to x. So in between negative 2 and 3, looks like that is a 13.7. Multiply 13.7 times 4, and you get what? 52, 53, 54.8, I think is a good number. 54.8. And that is it for number 4. Again, you turn your lower limit and upper limit upside down. You have to put a negative sign here. I think just for the sake of doing it, I'll just mention that to you. The Fundamental Theorem of Calculus says that this is f of b minus f of a. If I turn my limits upside down and put the b on the bottom and the a on top, the only way that changes the problem is now I have to substitute the top limit in first. So now I have f of a minus f of b. These are opposites of each other. If I multiply one by a negative sign, I just get the other. Let's just say, isn't 10 minus 12 negative 2, where 12 minus 10 is a positive 2? They get the same answer, just one's positive, one's negative. So if you turn your limit upside down, you get the opposite answers you would have otherwise. Therefore, throw a negative on the outside of your function and you're good to go. Okay, so we're done with number 4. Question number 5 asks you to find f of 3. I'm given f of negative 7 is 10, and now I want f of 3. So I want to go from negative 7 to 3, and it looks like I was actually given the integral from negative 7 to 3 as well, so I'm going to be set with this. The concept we're going to use here is that start plus change is equal to end. And I'm going to start with my leftmost bound, the negative 7, f of negative 7. I'm going to end where I want to be, f of 3. They have to go in this order too. I can't put the f of 3 here and then f of negative 7, because I want to read my graph from left to right, and negative 7 is to the left of 3. So this is the order in which they have to be. The change has to be the integral between negative 7 and 3 of my first derivative graph. Now here I'm switching to f prime because I'm using the f notation here, but this is still g. Okay, so f of negative 7 is 10. This is the integral between negative 7 and 3, which, silly me, the integral between negative 7 and 3 is negative 10.8, so I'm going to put negative 10.8 right here, and that's going to give me f of 3. I like to circle the thing I'm trying to find. That way I know that everything else gets substituted. This gives me negative 0.8 for my f of 3. So I'm going to come back up here, and I'm going to put negative 0.8, box that. I'm also coming over here, and I'm putting negative 0.8 on that list. Okay, 5 is done. Let's try for 6, and then maybe we'll take a break a little bit. 6 goes from negative 12 to negative 2 of g of x dx, which is a big question mark. So I'm looking for the integral between negative 12 and negative 2. I want to know what is the net change in the height of the original function f between negative 12 and negative 2. So common sense tells me the original function f is going to increase 24.5 between negative 12 and negative 7, and then decrease negative 24.5 between x equals negative 7 and x equals negative 2. So I'm going to be right back where I started with. So therefore, f of negative 12 is going to be the same answer as f of negative 2. I'm not sure what it is yet, but they're going to be the same exact thing because the net change is 0. Let's see how this pans out. This is going to be change plus change equals total change. Alright, my first change is going to be the interval from negative 12 to where does the graph break the x-axis again? Negative 7. Plus the change from negative 7 to negative 2 will give me the total change from beginning to end from negative 12 all the way to negative 2 of g of x dx, which of course is my original question. So all I have to do is fill these in. The integral between negative 12 and negative 7 is 24.5, and the integral between negative 7 and negative 2 is a negative 24.5. You add those together, they're opposites, they give you 0 for the integral between negative 12 and negative 2 of g of x dx. So this is, like I said, a 0 net change or total change in the original function f between x equals negative 12 and x equals negative 2.